Equivalence relations. An equivalence relation on a set S is a set R of ordered pairs of elements of S such that 1. A comma A is a member of R for all A member of S. This is known as the reflexive property. 2. A comma B is a member of R implies that B comma A is also a member of R. This is known as the symmetric property. 3. A comma B is a member of R and B comma C is a member of R implies that A comma C is also a member of R. This is known as the transitive property. Now, whenever we're discussing an equivalence relationship R on a set AS, it is customary to write A RB or A tilde B instead of writing A comma B is a member of R. So if we have an equivalence relationship R, we will just say that A is related to B instead of writing A comma B is a member of R. Let S be the set of all triangles in a plane. Consider any two arbitrary triangles from the set S. Define a relationship between A and B such that A and B are similar triangles. Similar triangles are those triangles that have corresponding angles to be equal. Then A is related to A because the triangles are equal and hence similar. Now if A is related to B, then since A and B are similar, B must be related to A as well. Now assume A is related to B and B is related to C. This means that A and B are similar triangles and B and C are also similar triangles. Hence, A is related to C. Since the reflective, symmetric and transitive properties are satisfied, we can conclude that tilde is an equivalence relationship over S. Consider the set of all polynomials with real coefficients. Call this set S. Take any two arbitrary elements from the set S and call them F and G. Now for F and G member of S, define a relationship tilde such that F is related to G if F prime is equal to G prime. All this means is that the first derivative of F is equal to the first derivative of G. Then, as F prime is equal to F prime, F is related to F. Now if F is related to G, then F prime is equal to G prime. Since G prime is equal to F prime, G must be related to F. Last, if F is related to G and G is related to H, then we have our first equation, F prime is equal to G prime, and a second equation, G prime is equal to H prime. Now, substituting the second equation into the first equation yields F prime is equal to H prime. This implies that F is related to H. Since the reflective, symmetric and transitive properties are satisfied, we can conclude that tilde is an equivalence relation over S. Now, consider the set R of all real numbers. Then for any x, y or z member of R, define a relationship denoted by tilde such that x is related to y if x is less than or equal to y. Note that the inequality less than equal to reads as less than or equal to and not less than and equal to. Then since x is equal to x, x must be related to x as the inequality x is less than or equal to is satisfied. However, if x is related to y, then x must be less than or equal to y. This in no way means that y is also less than or equal to x. For example, consider the relationship between 4 and 6. 4 is less than 6, hence the inequality 4 is less than or equal to 6 is satisfied. But 6 is not less than or equal to 4. Hence the symmetric property does not hold over the set of real numbers when the relationship considered is an inequality. All in all, such a relationship is not an equivalence relation.